Pizza problem. We have a situation. We're going to look at the question first. How many pizzas can you serve tonight? So we're looking, I'm going to underline the words how many, because that's going to help us know what we're looking for and how what we're going to do to define our variable terms. So let's read the paragraph above. You run an Italian restaurant. In addition to various pizza specialties, you also make either large pepperoni pizzas or small cheese pizzas. So let's go ahead and highlight that part that tells the two types of pizzas they have available. I'm going to highlight it in yellow. It says the large size requires a pound of dough and the small size takes half a pound of dough. So I can highlight those pieces and I'm going to highlight that with an orangish color. Okay. Each large pizza takes a quarter pound of pepperoni. So each, you see that word each, we know that's going to tell us that's a rate. And make that sort of greenish. And that you have 5 pounds of dough and 4 pounds of pepperoni in the freezer. So I'm going to take that part where it tells me how much I have for my limitations. And that's going to be blue. So I've got a lot of information to look at. Let's go ahead and define our variables. We're looking for how many pizzas. And we have two different types of pizzas. We have large pepperoni pizzas and small cheese pizzas. So in defining our variables, I'm going to go to the next slide. I'm going to say x is equal to something. And then I'm also going to say y is equal to something else. So x, looking back here, large pepperoni pizzas, I'm going to make that my x value. Large pepperoni pizzas. That's a really big font. And so if the x is our large pepperoni pizzas, then y is going to be our small cheese pizzas. Okay? So we know our variables. We're going to now go ahead and write our inequalities. So there's two things that we know in here. We know how much dough we have and how much pepperonis we have. Those are the two pieces of limitations that we have here. And we're going to use the information we have in our paragraphs to help us write our inequalities. So if we look at our sentence, we see that a large size requires a pound of dough, a small size requires a half pound of dough. So these are going to be like the rates for these. So we're looking at our dough is one of the limitations we have, the amount of dough we have. The other limitation is that we have a certain number of, and then down here we say each large pizza takes pepperoni. So we have 50 pounds of dough and 4 pounds of pepperoni. So the two limitations are the dough and the pepperoni that we have in the freezer. So let's write our first equation based on the dough. We're told how much does each one of them take. The large one takes 1 pound, the small one takes a half pound. So I'm going to write this as an inequality. 1 times x was my large plus 1/2. So I'm going to put 0.5 actually times y. And we only have 50 pounds of dough. So we have to do less than or equal to. We can use up to that amount. So less than or equal to. It's going to be less than or equal to 50. For the pepperoni, we have only, they're not using the pepperoni on the small pizzas, only on the large pepperoni pizzas. So the large pepperoni pizzas, each pizza requires how much pepperoni? It says a quarter of a pound of pepperoni. So, and we only have 4 pounds of pepperoni. So I'm going to write my variable of pepperoni as going to be 1/4 pound. So I'm going to write 0.25. That's the same as 1/4 pound times x is less than or equal to, again, 4, because that's how much we have in terms of our pepperoni. So I'm going to take my equations, my inequalities, and I can put them into Desmos to go ahead and make the graph now. So my Desmos graph, I'm going to put in my first equation, which if I look at my equation, it's going to be 1x plus 0.5y is less than or equal to 50. Again, we can't just copy and paste. We need to type it in. 1x plus 0.5y is going to be less than or equal to, so the arrow is pointing to the left, 50. 50. So there's my first inequality. My second inequality back here I see is 0.25 is less than or equal to 4. So I have 0.25. Oops, let me put the 0.25, and that's x, because that's only dealing with pepperoni pizzas, is less than or equal to 4. So there's my other one. So I have, my graph looks like this. But again, we can't have negative numbers, so I'm going to do negative quantities of anything. So I'm going to say y is greater than 0, close the curly brackets, x is greater than 0 also. So now I have a nice little triangle. On the other one, I'm going to say y is greater than 0, and x is greater than 0 also. Close the curly brackets. So now I have a graph that looks kind of like this. But let me go ahead and label my axes. Go up to the wrench. We said x is representing the large pepperoni pizzas. And then y is going to represent the small cheese pizza. So my axes are now labeled. And I'm going to find a point on my graph that's going to be inside the shaded area where it overlaps. So I've got my, this is representing the amount of pepperoni we have, this is representing the amount of dough we have, and the part where they share the overlap is where I can make this work. So I'm going to do an ordered pair, and this is the ordered pair I'm going to do. I'm going to do 12, 60. I just randomly selected that. And it's right smack in the middle of our shaded area that they share. Okay, so I can zoom that in a little bit and I can see the point a little more clearly. I'm going to download that and load that into my slide presentation. So I went to the share up here, click export image, change my line thickness to medium, and download PNG. I'm going to drop that into my presentation, go to the image icon, click upload from computer, select my Desmos graph and open it, and I have now my graph is ready to insert. So I'm going to type my ordered pair over here, which my ordered pair was 12, 60, and that's the point that I'm going to use to verify on the next slide. So on the next slide, I'm going to take my ordered pair, my equations. I have the 1x plus 0.5y is less than or equal to 50. And then I have 0.25x is less than or equal to 4. So I'm going to copy those two and paste them into my spaces here. So I'm going to substitute in for x, I'm going to substitute in the value of 12. For y, I'm going to substitute in the value of 60. So I'm going to say 1 times 12, taking out the x, replacing it with 12, plus 0.5, take out the y, replace it with 60, is going to be less than or equal to 50. So I only replaced my x and my y. Let's go ahead and simplify. 1 times 12 is 12, plus 0.5 times 60, or half of 60 is 30, is going to be less than or equal to 50. 12 plus 30 is 42. and that's less than or equal to 50. So 42 is less than or equal to 50. That is true. On my other equation, I have 0.25x, so I'm going to say 0.25 times, what was my x value? It was 12, and it's going to be less than or equal to 4. So 0.25 times 12, if you can't do the math on your own, then you just go ahead and use your Desmos calculator. 0.25 times 12, and that's equal to 3. So I have 3 is less than or equal to 4, and that is a true statement. So I'm going to go ahead and explain what this means. We were looking at how many of each type of pizza we can make. That's our question going back here. How many pizzas can you serve tonight? So we're going to look at how many large pepperoni, how many small cheese pizzas. So you can serve, I can say I can serve, let me make this a little bigger font, I can serve, X was our pepperoni pizzas, 12 pepperoni, and I can serve 60 cheese pizzas tonight. And that basically explains the context of my solution that I came up with. Now, your solution might be different. You can come up with lots of different points that are inside of that shaded area, and so there could be any number. We could even do it so we have 40 and something. The limitation here, of course, is the number of pepperonis, which means that the most we can make are 12 pepperoni pizzas. Or actually not 12, but whatever our line was, it's going to be up to 16 probably. Okay? So you're going to use these same steps to solve the other ones, and moving on to the next one is going to be on the candles problem. So we've got, I want you to highlight the key pieces of information, underline what we're looking for, and define your variables. You've already been given one variable, which is the number of small candles. You'll figure out how to do the other one. You're going to write your inequalities, and then you're going to make your graph, and then find a point of intersection that's going to be in this shaded area that's overlapping. So sort of like the red and the blue here, it's where I have a red triangle and I have just a blue strip. Where they overlap, it's sort of purplish. That's where you're going to find your solutions.